Hi everyone. Today we are going to discuss how to design a footing of a structural building. We know in the total load of the building is transferred to the footing to the soil to the footing. We know there are roofs and there are beams and there are walls and columns and slabs. All the loads are transferred to the soil through the footing. So then let's discuss how can we design this kind of footing. So this is the ground floor level. This is the ground floor level. Ground floor level. Let me show how to design a footing under this ground floor level. Okay, I will erase this one. Then I will draw a structure of a footing. This is the column. This is the column. In every column, we should provide the footing. So this is a column. And this is the footing. This video will be help for the civil engineering students and those who are working in civil field. This is a 3D view. Then let's discuss how to find this size of the footing. Okay, this is the column. This is the footing. I will take size of the footing fx for this direction, fy for this direction. That means fx is here to here, size of the footing. Fy is here to here. Then let's identify how to find these values. This is fx, that means size of the footing for x direction, for size of the footing for y direction. And I will take size of the column for x direction. This is cx, size of the column for y direction, cy. Okay, let's identify how to find these values. This is the column. And this is the ground level. This is the ground floor level. Okay, first of all, I need to know what is the area of this 14. First of all, let's find area of the 14. Area of 14. Area of 14 should be equal to load over soil bearing capacity. Area of the 14 should be equal to load over soil bearing capacity. Then let's identify what is load, what is soil bearing capacity. If we are designing a building, there is a load, that means we called design load. But if you have a civil engineering student, that means you are a civil university student, they will provide this data for your calculation. They will provide this data for your calculation. For this calculation, I will assume the total load applied to this column, applied to this routine through this column, 3000 kilonewton. I will take 3000 kilonewton as an example. The total load has applied to this 14. Then you may have a question. How can we find this total load? I will discuss it from another video, how to calculate the total design load of a column. As an example, I will take this load is 3000 kilonewton. This is the load. And we need the soil bearing capacity. The soil bearing capacity mean the load that can be bear from the soil. it's a variable. It's depend on the soil. It may be a clay soil, it may be a sand soil, whatever it is. It may be there are some rocks also in the soil. So according to the soil, it is a variable. So for this example, I will take the soil bearing capacity. For this example, I will take the soil bearing capacity. Normally, in the short form, we called soil bearing capacity SBC as 350 kilonewtons per square meter. For this is an example. If you are a university student, they will provide this one as a data. But if you are a civil engineer, you need to find what is the soil bearing capacity of this soil. I will provide this detail in another video. For example, I will take this is 350 kilonewtons per square centimeter. Okay, then let's go to find the area of the footing. So area of the footing should be equal to the load. The load they have given 3000 kilonewton, but keep in your mind for our safety factor, we should add 10% of the design load. We know after the design that load may be variable according to the usage of the building. Then it may be a variable. So I will add 10%. That means we should add 10% of the load for the design load. So the 3000 plus the 10% is 10% of the 3000 is just 300. So 3000 plus 300, this is the total load that we have going to find, kilonewton. Over soil bearing capacity, I told you we should find it, but as an example we got 350 kilonewton per square meter. 350 kilonewton per square meter. But there is something you should consider. Normally, if you are a university student, they will provide the data, then you can just put 350 for soil bearing capacity. But in a site practice, that means if you are a civil engineer or you are a construction worker, you should take the 50% of the soil bearing capacity. It is good for you. Why? We don't know the exact condition of the soil. We are taking decisions of the soil with the current availability, but the soil may be a variable. It will be changed in the future. So for our safety purpose, it is better to take half of the soil bearing capacity. That means it is better to take 175 for here in our site practice. But if you are a student, if you are just doing for the exam, you can just put 350 for the soil bearing capacity. Let's find the answer. The kilonewton and the kilonewton is cancelled. 3000 plus 300 means 300. 3300. You can just divide that 3300 from 350. The answer is equal to 9.428 cubic meter. This is the area. That means we found the area of this footing. This is the footing. We found this area of this footing. Then I need to find fx and fy. That means length and width of the footing. Okay. Please pause the video and you can write this one and let's find fx and fy. Okay, we found this area. I will take this area of footing as AF. Area of footing is equal to 9.428 cubic meter. Then I am going to find fx and fy. I will draw the 2D version of this 14. That means bird view of this 14. This is the 14 and this is the column. This is the 14 and this is the column. Okay, this is fx. This is fx and this is fy. We are going to find fx and fy. For an example, I will take the size of the column 250 into 250. That means 10 inches by 10 inches. 250 millimeters into 250 millimeters. So this is cx, this side, and this side is cy. Okay, we found the area. That means area of the footing AF is equal to 9.428 cubic centimeter. We know this is a square. There is something you should consider: size of the column. The size of the column, that means cy and cx is equal in this case. That means the column is just a square. Then no need to worry about the size of the footing. If the column is like square type, that means the cx and cy is equal, nothing to worry. The footing also should be just square type. That means you can just take this is a square. We know how to find the area of the square, that is uh, square of the one side. So that means definitely you can say fx is equal to fy. That should be equal to square root of af. So square root of af means square root of 9.428. So the square root of 9.428 should be equal to, you can find it by using the calculator, 3.07 meters. So we found this length should be 3.07 meters, and this one also should be 3.07 meters. That's how we are find the fx and fy of a 14 if the column is square type. But there are some columns with the rectangle type. Then let's identify how to find that values. Okay, please pause the video and you can write the answer, and let's discuss the next one. Okay, now let's draw the bird view of the new 14. Now the column size has been changed. For an example, I will take a rectangular type column. This is the 14 and this is the column. For an example, I will take 300 into 4050, 450. I will take this is as 300 millimeters. That means 1 feet. This is 450 meters, and that means 1.5 feet. This is the column. This is not a square. This is a rectangular type. So we need to find this fx and this fy. But for an example, for simplification purpose, I will take the same load and the same soil bearing capacity. That means it won't change the area of the footing. For the simplification purpose, I got the same load and the same soil bearing capacity. So the F is still Fs AF is still 9.428 cubic meter. So this is the area. Now we are going to find AX and AF. And you should remind this one, column is not a square type. This is just a rectangular type. So first of all, I will find how to find fy. Then to find fy, you need to know cx and cy. That means size of the column. We got this is cx, this is cy. First, to find the fy, you need the difference of cx and cy. That means I will write cy minus cx. You can change this one. That's why I will take the modulus. The modulus means if I change this one, it present the positive answer by over 2 plus difference of cx and cy square. That is also okay. You can change the cx and cy. If you take the square of a number, definitely should be a positive answer. Over 4 plus area of 14 square root. This is the formula for the Fy. Then let's simplify. Cy. This is 450 millimeters. But keep in your mind, we can't put millimeters. For the simplification, we should provide answers with the SI unit, that means meters. You have to convert 450 millimeters for the meters. This is equal to 0.45 meters minus 0.3 meters divided by 2 plus 0.45 meters 0.3 square over 4 plus AF. We found the area of the 14, that is equal to 9.4 9.428 square root. Then we can find the answer. You can just simplify. You can use a calculator and just simplify. You will take 0.45 over 0.3 means 0.15 over 2 means 0.075 plus. You can just simplify this one. This will be equal to 3.07. So the final answer may be 3.146 meters. This is the answer, 3.146 meter. Okay, this is the answer. That means we found Fx. That means length of the 14. I will write the answer. We found Fx as, we found Fy as 3.146 meter. We found the Fy. Now let's discuss how to find Fx. Then I will erase this one. You can just write, you can just use the video and you can just write the answers. Okay, now let's come to find the Fx. Now it's easy for us. There is something I have to say you. Can you remember I told you, if the column is square type, nothing to worry about this equation. Why? If the column is square type, Cx and Cy is equal. Then Cx and Cy will be cancelled. Then here also Cy and Cx is cancelled. So this is equal to 0. This is equal to 0. You can just take the square root of AF. That's why we got the answer quickly. But this is a rectangular type. We need to use this formula. Okay, then let's come to find Fx. Now it is easy for us. Why? We know this is just a rectangle. This is just a rectangle. We know the area of the rectangle and we know the one side of the rectangle. We can find the remaining side. So the remaining side Fx should be equal to the total area AF over Fy. This is just simplification. So Fx should be equal to AF. We found 9.428 over Fy. We found 3.146. You can just divide this one. It will be equal to 2.996 meters. Then we found the Fy and Fx of this 14. So this is equal to 2.996 meters. So we found the Fx and Fy of the 14. These are the details. And there is something I have to tell you. I promise you, I will provide how to find design load and I will provide how to find shape bearing capacity of soil. And I will provide how to find the column size of this 14. That is also maybe a question for you. That is depend on the structural load. So then I will provide another video how to find size of the column. And there is something tell you what is the height of this 14. The minimum, as an explication, the minimum height should be more than 150 millimeters, that means 6 inches, it is better to take the minimum height of the footing 300 millimeters, that means 1 feet. It is better to take more than 300 millimeter to this kind of footing, because this is just equal to 3 with then fx and fy is equal to just equal to 3 meters. No, it's better you can take 300 millimeters of the height. And there is another thing you have to consider: what is the height of the footing, that means depth of the footing. What is the depth of the footing? That means what is the depth to the footing from the ground level? If this is h, we should know to find that one. So there, for that one, we are used the Rankine formula. Rankine's formula. I will provide another video how to find the depth of the footing. Those are the things we had to discuss by using this video. Okay, let's stop this video and we will meet with another one. Thank you.